how many variables do we have? Okay. And how many equations do we have? So we can solve it. I organize. Let's start with equation 1, equation 2, and equation 3. Now this is not going to have all the steps. This right here is actually going to just show you something called back substitution. Do you see how we already know one of the variables' values? Okay. If I know that z is 2, what could I do with that knowledge? I can plug it into 2. So I'm plugging it into equation 2. So we'll have y plus 3 times 2 equals 5. So y is negative 1. So if I know that z is 2 and y is negative 1, how would I find x? We're going to go back and plug it into equation 1. X minus 2 times negative 1 plus 3 times 2 has to equal 9. Okay, so this is where these 3 equations would intersect. Do you guys know what it is like to graph with 3 equations? 3-dimensional. Did you guys talk about that in honors last year? I think I mentioned for half a second in CP, but it was the very beginning of the year. If we have 3 variables, it's not just x and y. I mean, that's 2-dimensional. So we've got this 3rd dimension that sticks out. And it's hard to tell by just looking at that, the corner of my room. Everybody's staring at the corner of my room right now. I'm trying to draw a corner of a room. Now just make a cube. So, you know, this is the door right there. There's my crazy poster on the door. Right here would be like an x-axis, and this could be the y-axis. This is connecting the ceiling and the front wall where there's my computer stuff. And then this right here would be right above the door where it connects the ceiling to the wall. So that would be 3-dimensional. So if you can't see this on video if you watch it, but if I just like take my hand, a point is a location. So if I just take my hand and I find, well, I'm going to go to the right this much, I'm going to go to the left this much, but as soon as I want to make it 3-dimensional, now I'm going to go this far out. Right? So that's what we're doing, is we're finding 3 lines that connect each other out in space rather than just on a flat line. We're not going to graph this one. Okay. We're just going to find where they cross. So when we do this 2-dimensionally, when we find like where two lines cross in 2 dimensions, how do we write our answer? What's this thing called? An ordered pair? Do you know what it's called? Dimensions? Ooh, no guesses? So this one's a pair. Do you know what pair means? Whoever said tripled pair? You're on the right track. Close. When if you put you together with, was that Peter that said that before? Oh, it's prob. It's not even over here somewhere. She said ordered trio. Let's put that together kind of with what you were saying. What do you think it's called? Ordered triple. That's what it's called. And we do put it in XY. Did you know there's 4 dimensions? Do you know? It could be. You're disagreeing with me because I'm like, does anybody know that there's 4 dimensions? Oh, I don't know. There's probably more. I remember Calc 3 in college being like, because we're doing calculus with 4 dimensions. So when I use my hand before this point, I go to the right, and then I go down, and then I come out to the 3rd dimension. Here's one example of 4 dimensions. The temperature over there was different than the temperature over here, so it's like how the temperature is changing as I move. Oh, I don't remember. That was a long time ago, like 20 years ago. And another dimension could be the time as I'm moving. That one makes a little bit more sense. But I remember the temperature. There was a question that was on our exam about like a ladybug that's moving across the plane, and then what temperature, and I don't know. I'd love to find that question though. That's the one question I remember from Calc 3. Okay. So anyway, that's basically what we're going to do. Now let's actually do a big gap. So, we're going to label 1, 2, 3, because if you want my help, you will stay organized. If this is unorganized and you're like, I can't find my mistake and I can't figure it out, and I look at it and it's everywhere, I can't put myself in that mess and try to figure it out. If it's organized, I'll have no problems helping you find your mistake. And you will make a mistake. Everybody does. Like you forget a negative somewhere and it messes everything up. We're going to be okay with making mistakes. Everybody has a pencil. Oh no, you have your stylus. We're good. You can make lots of mistakes. Okay, so the first thing that we have to do is we have to eliminate basically a whole equation. We have to get 2 equations from 3. We have to eliminate one of the variables completely. So I go over here and I look at my x's, I look at my y's, and I look at my z's. And I decide what do I think is going to give me the least amount of work to try to eliminate. Amelia, do you have an opinion? Okay, so you're a little bit ahead of me. What variable do you think we should eliminate? Z. I'm thinking Z as well. I also think that X wouldn't be bad. I think that Y would be a little bit more work. There is not a wrong answer. It's just some might be more work than others. So let's eliminate Y. I'm sorry, Z. And I'm going to write this down because we're not going to forget what we did. And then when you come up and ask me questions, I'm going to be like, what were you trying to eliminate? It's already written down. I don't have to ask you that question, okay? So we're going to eliminate Z. So then Amelia kind of knew what to do next. She said, let's use equation 1 and equation 2. So notice how I'm writing down 1 and 2. And I'm copying that entire equation over. X minus 3y plus z equals 2. 2x plus y minus z equals 5. Why do I make my z's weird? Yeah. When you know I have this much paper available to you because we're going to fill it. And when you got that much stuff going on, you don't want to make a mistake like think your z is a 2. Okay, and we're going to use elimination with this. Add this up. I've got 3x. I've got minus 2y. My z's are eliminated, and I get equals 7. I'm going to call that equation A. I'm just trying to stay organized. I'm going to call that equation A. So I have 2 variables. I've eliminated z. However, in order to solve for 2 variables, how many equations do I need? So I'm not ready to solve for 2 variables yet. I have to repeat the process I just did. I have to eliminate z a second time, but I can't use equations 1 and 2. I can use 1 and 3 or 2 and 3. Okay, so I'm going to eliminate z a second time. Maybe I'll change my color now. I don't know. Eliminate z again. And I'm going to go with somebody else's opinion because there is not a wrong answer. Should we do eliminating z in equation 1 and 3? Or should we use equations 2 and 3 to try to eliminate z? There's not a wrong answer. I was just going to say why 1 and 3. Just curious. Oh, you're looking at the x's? And then why were you saying 2 and 3? Because these are already negative. See, there's not a wrong answer. There's not a wrong answer. Is that what you're going to say? Okay, so let's do 2 and 3. If you want to challenge yourself, you can do the others, but maybe just do it all the same way this time. Okay, so in order to do 2 and 3, though, I need them both to have 3's, and this one does not, so we multiply everything by 3. Equation 2 is now going to be, this is one place people make mistakes, especially talking, and I'm doing it at the same time. I tend to make mistakes. Try not to. You guys check my work. So when you multiply that 3, sometimes forget to multiply one of the numbers by 3. Just like silly mistakes. Then we're going to add those together. And I'm going to call that equation B. So this next step, I don't normally write this next step, but I'm doing it the first time because we're learning. This next step, we now have 2 equations with 2 variables, a and b. I don't normally just rewrite them. Just doing it this one time. If you want to rewrite them, and just so they're on top of each other. Yeah, thank you. See, when I start talking, I make mistakes. So I'm just writing them on top of each other. So now I can ask you guys, like, what should we try to eliminate? Or we could do substitution, but I tend to do elimination most of the time. Substitution's not, like, you can totally use it still. What should I try to eliminate? Why? All right. There's not like one that you have to do. So sure. Let's try to eliminate our y here. So we're going to multiply this one by what? 7. And multiply the other one by 2. I need another color. So my new a. Did I do my math right? Oh my gosh, why do you need a calculator? Just here, probably over there with his. All right, you're checking. Got it. Did I do my math right, Prob? Since you're checking anyway. So then if I divide both sides, oh wait, I got down to an equation that only has one variable. So I just need one equation with one variable. I can solve for x. Divide by 35. What does x equal? 3. We found one answer. So in the previous example right up here, I had given you one answer. What did we do with that one answer when we knew the one answer? we plugged it in where? To a different equation that had what? Only two variables. So we're going to use what's called back substitution now. And we're going to plug this x equals 3 into an equation that only has two variables. Are there any equations here that only have two variables? A or B? Your choice. What do you want to plug x equals 3 into? Somebody said A? All right, why not? So we're going to plug in A. You can plug in the original A, or you can plug in the new A, but the new A has bigger numbers, so I'm going to go original A. And once I plug that in, now I just have y to solve for. Oops. So I now have two variables. What should I do with x and y to find the third one? I'm now going to go back to either equation 1, 2, or 3, and I'm going to plug it in. Your choice. Usually if they all look about the same, I'll probably go in the order. I'll probably just plug it in 1 because we still have to check. So I'm just going to plug it in 1. I need a color. And plug in 1. And plugs in equals 2. So what are we checking? Both. Sorry. We check in 2. We're going to go ahead and do that. And then after you check in 2, then we're going to check in 3. So you'll see that my work is set up. So like this is where all my AB stuff is. And then finally I'm doing plug in 1, check in 2, check in 3. So I don't do any of those steps. All right, check in 2. After you plug in 1, plug and check in 2, check in 3. If everything checked out, that means you did it correctly. We have our ordered triple answer. So it's just that easy. You all remember doing this last year? You know, I had so many Algebra 2 students that this was like their favorite thing that they did. Was it your favorite? You remember doing that? Rob, was it your favorite? Probably not. Nah. You liked it? Not Katie. I just remember it was, you guys know how I give you those questions. It was like at the beginning of the year, and one of the questions on a test or quiz was like, what's the favorite thing you've done so far? And everybody was like, this! What? It's the hardest thing we've done so far. Are you guys good? Well, you need a plug And I mean, 1 and 2. Yeah, you need to like hit this and it's worth like 25 points. Having everything there is how you're going to get your full credit. Yeah.
Like you plug the variables all into like one of the initial things you had.
Well, I did that here.
I thought you just plugged in
So this column right here is using equation 1, equation 2, and equation 3. So I did have to use the original. And like when you do your plug and check, do not use the equations that we like multiplied. Don't use those. Use the originals. I don't know if I answered your question.
Yeah.
I did use the original ones. Okay. Let me try it again. Let me try again. Is that okay? No? It's all right. We actually have 1, 2, we have 3 more examples today. That's it. I think, I'm sorry? You don't have 2B? I wonder why I put 2B in but didn't give you 2B. Do you want to try? Let's try. Oh, this is normally, I probably cut it out. Normally, I don't like I'm not putting more stuff with this on a block day. Let's just do this. You guys have like notes. Like on Cami, you have like note. No, or not Cami, but like, do you know what I'm talking about? Can you do that? You have to pay? Okay, don't you just have notes on your computer? Like a notepad? Like a notepad? So open up a notepad. I'll zoom in so you can see the question. And let's see if there's a place that you get stuck on this. Here's the hard part. Remember how I say, what do you want to eliminate? There isn't a wrong answer. So there isn't a wrong answer, meaning you're all probably going to pick different things. So it's going to be very difficult on me to look at every single individual paper and tell you what you did wrong. Take your time. I mean, I will try. I will try to find what you did wrong. Stay organized and take your time. And then if you forget what to do, call me over. I'm going to pause this video so you guys can just try this. Okay, for example 3, we need to find the quadratic equation in the form of y equals ax squared plus bx plus c, whose graph passes through the following points, -2, 5, -1, 5, and 0, 1. And this says set up as a system of equations. So what you need to do is you will have 3 separate equations for this kind. And when we look at our information provided, up here there are 3 ordered pairs. Each of those ordered pairs is going to help you make one of these equations. So my ordered pairs xy, we've got -2, 5. -1, 5, and then 0, 1. Oops. And then when I talk about setting up an equation, you look over here and you're trying to find, oh, what equation do I use? Here's the equation we're going to use. And each of these is going to have 3 unknowns. And when I look at this equation up here, the ordered pairs are the x and the y. The ordered pairs are the x and the y. So the 3 unknowns are going to be the a, the b, and the c. So when I plug in this ordered pair, y is 5. And we don't know a. but we know x is -2, so I have to put that into the equation and square it, plus b, and then x is still -2, plus c, and there's nothing with c. I'm going to do the same thing for equation 2. I take my y value, and we're going to do a multiplied by -1 squared, which is our x, plus b times -1 plus c. And then for my third equation, our y value is 1. We have a times 0 squared plus b times 0 plus c. So this is going to be the 3 equations, and our 3 unknown variables are going to be the a, the b, and the c that we are solving for. Before I even start that, I think I'm going to make these look a lot nicer by getting rid of the squared and getting rid of the parentheses. So 5 equals -2 squared is 4a, and then -2 times b is -2b plus c. We've got 5 equals -1 squared is 1, so a plus minus b plus c. And then the third one, 1 equals, if I take 0 squared it times a, it's still 0, plus b times 0 is 0, so I just have c. Okay, so now we're just going to solve like we did the first few examples. We're going to solve to find a, b, and c. If you look over here, what do you think we should do? Any ideas? Substitute what? C equals, I already have an answer. C is 1. Substitute, I'm sorry. Can we plug it into both of them? What's that going to do for me when I plug it into both? 5 equals 4a minus 2b plus 1, and 5 equals a minus b plus 1. So we have eliminated one of the variables, and we've done it. So we've gotten down to 2 equations with 2 variables. Maybe I don't like the way they look. By the way, this would be like my a and my b. I called them 1 and 2 because that's what I was plugging them into. But this would be like my a and my b equations. I might not like this plus 1 over here and the 5's over here. It doesn't really matter. I don't like it, so I'm just going to rewrite these. 4 equals 4a minus 2b, and 4 equals a minus b. So if we have eliminated one of the variables, what do we need to do? Eliminate another one. What do you want to get rid of? A or B? B? Sounds good. We're going to get rid of B. We're going to multiply the second one by 2. So my B is going to be 8 equals 2a minus 2 little b. Get 12 equals 6a. Oh no. Yeah. So that's going to have to change to be -8. And -2 and +2b there. So now we have -4 equals 2a, and now they eliminate. A equals -2. So I know that C is 1 from my original plug-in. I know that A is -2. What should we do now? Plug them in where? To the first equation. The first original equation, this one here in red. I'm going to plug them in 1. I did this weird. I don't know why I wrote down the center, because now I could fit it in here. Sorry. Plug in 1. 5 equals 4 times -2 minus 2 times, I don't know, b plus 1. Like, yeah, okay, sorry. 5 equals negative 8. It's 2b. This one. Did anybody get negative 6 for B? Did I do, no? She did. Did I do it wrong or did you do it wrong?
Well, I punched it and I checked all of it.
Oh, you've already done it?
Oh, keep going, maybe.
Okay. Did anybody else get negative 6? I felt like I was like not focusing enough. Peter? Oh, you didn't. Okay. That was you raising your hand for like agreeing. Okay. It's possible I make a mistake too. So, all right. So if I plug in 1, now I'm going to check in. Did you check in 2 next, Emily? Amelia, sorry. Did you check in 2?
Yeah.
Okay. So if we check in 2, we're going to do 5 equals our A value is negative minus A, which is negative 6, plus our C value, which is 1. So 5 equals 4 plus 1? Yep. And then I'm going to check in 3. Oh, 1 equals 1. Okay, that one checks. So now when you checked yours, what B value did you have?
I got A equals 2, B equals 2, 1, and I checked all of them and I put 4. So I'm sure.
No. I'm just thinking right now. Are your equations the same as mine?
Number 2.
Okay, so that's one thing that does happen. So Amelia made a mistake when she was just simplifying her equation. I'm guessing you forgot the negative b. She just put b. Okay, but that's why everything checked. So I do have an extra check for you for this one, just to make sure. I do have an extra check because everything here checked for her wrong answers. She would not have known she was wrong because it all checked out. And it's because she had made a mistake on writing the original equations. So I'm glad that you made that mistake so we could talk about it. Before I go show you that extra check, my answer is not in order triple. Like I know that A is negative 2, B is negative 6, and C is 1, but my answer is not in order triple. What was I asked to do? Write the equation. So I'm actually going to put the A, the B, and the C into the equation. So my equation, I'll write it over here, should be y equals, our A value is negative 2x squared, our B is x, and our C is 1. So here's an extra check for you. If you're confident, here's an extra check for you is all 3 ordered pairs should fit in the equation. So if I plug in 5 equals negative 2 times negative 2 plus 1, it should check. That's what we're finding is the parabola that goes through all 3 of these. Do you mind telling me the equation that you had that was wrong?
Oh, it was number 2.
No, I mean like the answer that you had A, B, and C, but there were different answers. What did you have? You had like what did you have for A?
Oh,
2?
I didn't put it in the equation yet. I just had it.
You had 2 for A?
Yeah.
Okay.
B was A.
Okay, so if I were just to check the first equation, no, it was the second equation was wrong. So if I were to check the ordered pair negative 1, 5 in this equation, 5 equals 2 times negative 1 squared plus 2 times negative 1 plus 1. Just to check that. Negative 1 squared is 1 times 2 is 2 plus, this would give me negative 2, 1. You see how it doesn't check. Okay, so that would be like the only possible way of checking it if you had the wrong equations to begin with. So there are people that make silly mistakes and write down the equations wrong and do all their work correct. If that were the case and it's worth 25 points, maybe you'll lose like 2 points for getting a negative up here. But you knew everything else. You know, you're not going to miss the majority of those points. Question?
Could you go back to second 2?
Sure. And then when you're ready to go on, we'll look at that last page. Beginning. So this is a similar question, different equation. This here is the equation of a circle, but it's a general form of equation. In this form, normally you're going to see circles like x minus 2 squared plus y plus 4 squared equals 25. This is like the graphing form, like transformation of a circle. But this would be if you... Okay, so we are going to find the equation of a circle that passes these three. Okay, so we have 3 points. 1, 2, 3. We're going to set up as a system of equations. How many variables up here, not the x and y, how many variable unknowns find? Equations. And to get those equations, we're using our 3 ordered pairs. We use this equation, but plug in ordered pair 1, then plug in ordered pair 2, then plug in ordered pair 3. So I'm plugging my x and y for 0, 0. This one's got to be way too easy. Okay, then I'll plug in 0, 2. So x's are zeros. Sorry, 0, negative 2 for y. And then 3, 0. That looks really messy. Simplify it. Okay, then we're going to go through our steps again. We need, from these 3 equations, to have 2 equations with 2 variables. Right now I actually have 2 equations with 2 variables, but I have a problem. My problem is I have 2 equations with 2 variables, but there's a problem with it. They're not the same 2 variables, right? Anybody have an idea? Like, what could I try? Okay, both of you were like, both did it at the same time. Me and what?
Like, will the bottom one multiply by B and the top one multiply by B? Like, make it
The bottom one multiplied by what?
E.
You want to multiply by a variable?
Yeah.
Let's not put more variables in. We want to get them out. We want to get them out.
Don't you know X?
Don't we know F? Okay. Now, you won't always be given such easy equations where you know F. A lot of times they're going to look more like the ones that we did at the, where is it at the beginning? Different page. More than often than not, they're going to end up being like 3 equations where you have like thing. Maybe you want to write down, because these are really easy examples to just get through in class. Your brain later to figure would be if you're going to eliminate. Say we have all 3 letters for all 3 of these. My suggestion would be to eliminate F each time, or twice, I should say. That would be my suggestion. I wouldn't eliminate F here because I know what F is. But most of the time, I'm going to eliminate F. Just a hint for you. If it's the kind where you have all the letters filled in. But this one, since we know F, we'll go ahead and plug in F to both of these. So I've got an equation A that is 4 minus 2E equals 0. And I have an equation B that is 9 plus 3D equals 0. I don't even have to do that much work. I can solve for E and D right now. I promise when you take a quiz, it won't be this kind. It'll be like the one with all 3 letters. If I know D, E, and F, how could I check it? Okay, so I could like, one's checked, okay. It's a really easy one. If I plug in E and F for one, four minus 4 plus 0 equals 0. Yep, that one checks. And then I plug in -3 and 0 for the third one. 9 plus 3 times -3 plus 0 equals 0. Sorry, that checks. Okay, so I just checked in. Checked in 2, I checked in 3, I checked in 1, I just didn't write it down. So our answer, we're going to plug in the D, E, F into the equation. X squared plus y squared. D is -3, so minus 3 x y 0, or just nothing. 0. So that would be our circle equation. And again, all 3 ordered pairs should work in there. All 3 ordered pairs should work in there just to check to make sure you're doing it right if you're unsure. You could also graph it on Desmos for now while we're just learning. You could graph this on Desmos and make sure that all 3 of these points, the circle passes through. That would be a good place to check our answers, would be on Desmos. Okay. There is a short assignment, and when I say short, these take a while, but there's not a lot. So there's a assignment. It is on our book, and I've posted it onto Canvas, but then I put something else there, so I need to draw your attention to this. There's a lot written there. Okay. This is not from Freedom. Asked me to do this before break, but before break with exams, we never got around to it. So he has a group of 6th graders, and they had to do a video about fallacy. Do you know what a fallacy is? Can you explain it, Neil? Did you say fantasy? No. I had to look it up because I'm not good at words. Does anybody know what a fallacy is? So I guess it's like making claims about something without having evidence. So when you watch their videos, they're trying their little hearts out. Some of it's hard to hear. Just go on there. And I was like, I don't know what you want my kids to comment. And she just wants you guys to like give them like a, good job, I enjoyed that. Oh, you know, like just give them some props. So I've asked you to go to flipgrid.com and then in that top corner enter NOP8216 and just comment on 2 videos. If you're going to do it with a friend, comment on 4 videos. It's a 2 of you, you know. If you're doing it with 3 friends, then comment on 6 videos. Yeah.
Do you have to, wait, is there like an option to like comment or do you have to respond?
It's video. It's video comment. I know. Get over it. And then we are, it's not on here yet, but we are going to make a math challenge video for them to actually do math. But I haven't decided what our topic's going to be yet, so we'll give them some hard stuff. Yes. Some of them are 5th graders taking 6th grade math.
Yeah, I'm scared of it.
My son's a 4th grader taking 5th grade math. He is scary. No, but your actual graded homework that you're going to bring in next time is from the book. There's how many questions? 8 questions. And on Friday, we're just going to have a itty bitty graphing quiz. It's written right there. It's just on the graphing. It's not on elimination or substitution stuff. It's just graph these 2 things, check where they cross. Short one. Okay? So you got to comment on at least 2 videos. Make sure it's not difficult to hear where you are. Go somewhere quiet. Use props if you want. I don't know. And then 8 questions. If you aren't doing it, then definitely.